What's up everyone, welcome back. Patrick here, moving on to the next example dealing with exponential functions. Here we are given a bunch of tables of values and we have to figure out whether these tables represent an exponential function or not. And I definitely wanted to go over an example like this because there's a lot of misconceptions about how you do these kinds of questions, and a lot of times they're taught in the wrong way. Or shall I say, they're taught in a limited way. They don't take into account all of the different possibilities. And so I'm going to clear the air in this video, and you're going to once and for all know, for any table of values that you get, how to see if it's an exponential function or not. Now, as a quick review, if you remember from previous grades, what makes a linear function? Y equals mx plus b? Well, if the first differences are constant, or if the first differences are the same. What makes a quadratic function? That's if the second differences are constant or the second differences are the same. So what makes an exponential function? Well, here's where the limited teaching comes in. So sometimes teachers teach it in this way, but it doesn't apply to all cases. And what they'll say is, well, you look at the y values of the table, again, assuming that your x values are going up by the same amount, which they are in all these examples, and you see, do the y values have a common ratio? Meaning that, are we taking the previous y value and multiplying it by the same number throughout to get the next one? And notice that in this case we are, right? We're multiplying it by 3, multiplying it by 3. 27 times 3 is 81. 81 times 3 is 243. So all these y values have a common ratio. Okay, another way that you can see if it's a common ratio, if you get like more complex numbers, maybe you'll get a bunch of fractions, is to take the bottom number and divide it by the previous y value. Take a y value, divide it by the previous y value, right? Take a y value, divide it by the previous. If you do that for all of them, they all equal the same number, which in this case is 3, they have a common ratio. The y values have a common ratio. And whenever that happens with the y values in the initial table, yes, it is an exponential function. However, it doesn't take into account all possibilities, because you can have exponential functions, and we're going to see that in this particular video with one of these next examples, where the y values don't have a common ratio, but it is an exponential function. Okay, so if, one more time as a conclusion, if the y values have a common ratio in the initial table, then yes, it's an exponential function. But if the y values don't have a common ratio, it's not necessarily true that it's not an exponential function. So how do we know, what's the general rule that we can use all the time to know if it's an exponential function or not? Well, what it is that the first differences have a common ratio. And that is the master rule right there. Or that's the master thing to check whether it's an exponential function or not, right? For any exponential function, for any table of values, any equation, the first differences always have a common ratio. It's not the first differences are the same or constant, that's a linear function, they have a common ratio. And so what we have to do is take the first differences, remember you always do bottom minus top, so 9 minus 3 is 6, this would be what, 18, 81 minus 27 is 54, 243 minus 81, that gives us 162. And notice that the first differences, they have a common ratio here. They all have a ratio here of 3, right? 18 divided by 6 is 3, 54 divided by 18 is 3, 162 divided by 54 is 3. So that means it's exponential. Now again, we didn't even have to take this step because the y values had a common ratio, and again, whenever that happens, you already know it's an exponential function. But again, it's not always going to happen that way, and you're going to see that in one of these next examples. You got to check the first differences, and if the first differences have a common ratio, that's when you know it's an exponential function. Or if they don't have a common ratio, that's when you know it's not an exponential function. Okay, so that's how you do it. You got to get the first differences, check if they have a common ratio. So part A, it is an exponential function. Yo, what's up? Quick little intermission here. I wanted to mention a few things and we'll get right back into the video. Number one, if you're watching this on YouTube, you can go to the description box and there's a link that will take you to my website, allthingsmathematics.com, and there you can find all of the videos organized by chapter, by section, and there's also tests that you could try at the end of each unit that have video solutions. Number two, if you feel like you need tutoring at any point, hit me up. I'm tutoring students 7 days a week over Zoom, both high school and university students, one-on-one and in groups. My contact details are on the website. You could text me and we could book a session. And finally, if you feel like you're getting any value from this video, if you could please like the video and subscribe to the channel, hit me up on all my socials. It does help me out a lot. If you feel like any of your friends can benefit, feel free to forward the website to them as well. And back to the video we go. Now let's move on to part B. So let's draw out this table quickly here. So we got x, y, 1 and 1, 2 and 7, 3 and 17, 4 and 31, 5 and 49. Okay, so notice right away, well, the y values don't have a common ratio, right? 1 times 7 is 7, but then 7 times 7 is 49. It's not 17. So, but again, that's not the thing that's going to show you whether it's an exponential function or not. So let's get the first differences here. 14 is going to be what? 18. And notice that these first differences, they don't have a common ratio, right? 10 divided by 6 is not equal to 14 divided by 10, which is not equal to 18 divided by 14. And only one of them doesn't have to equal, not all three of them. So we could have had maybe like, let's say we had like a 6 here, a 12 here, 24 here, but then over here we had like a 38. Well, 12 divided by 6 is 2, 24 divided by 12 is 2, but 38 divided by 24 is not 2. So then if we even had that, then we would know it's not an exponential because all of them have to have a common ratio, right? So as long as one of the ratios are not equal, then right away you know it's not exponential. Okay, so this one, part B, is not exponential. And then even though they're not asking for this, you could tell the second differences, those are actually constant. And when the second differences are constant, we know that it's a quadratic, right? So this one is a quadratic, it's not an exponential. Again, they weren't asking though what type of function it is, they're just asking is it an exponential or not. First difference is didn't have a common ratio, so we know that it's not exponential. Okay, so part B is not exponential. Now moving on to part C, and I mean, you're probably guessing now what part C is going to be, the answer to it, because I mentioned it at the beginning of the video that we're going to deal with a case where if you look at the initial y values, notice that the initial y values here, they don't have a common ratio, right? Negative 6 divided by negative 8 is not the same as negative 2 divided by negative 6. It's not the same as 6 divided by negative 2. But again, that's not what tells us whether it's exponential or not. We got to find the first differences. Negative 6 divided by negative 8 is 2. Be careful with your signs here. Negative 2 minus negative 6 is 4. 6 minus negative 2 is 8. 22 minus 6, that would give us 16. And notice the first differences here, they actually have a common ratio of 2. And because the first differences have a common ratio, we know that this is going to be an exponential function. All right, so be on the lookout for these. And be on the lookout if your teacher, perhaps, is teaching this in a limited way. It's not just the y values that have to have a common ratio. The first differences have to have a common ratio for it to be exponential. And if the first differences don't have a common ratio, then it's not exponential. And that is the end of the video. Hopefully you enjoyed that. If you want to find more videos like this, you can go to my website, allthingsmathematics.com. Over there, all my courses are organized for both high school and university. All the videos are organized by chapter. Also, if you have any questions, you can hit me up. My contact details are also on the website. Enjoy your day, and I'll catch you in the next one. Peace out.